perpendicular lines, as you can see, thank you, Baka, are lines that intersect at 90-degree angles. So it is never a good idea to assume that two lines are perpendicular. Okay, you must be given some sort of information, which we'll talk about just after this. So let's look at our example here. AB would be perpendicular to XY. Okay, that's how we would state this. And we know that because we have been given the 90-degree angle over there. Even if lines look like they're at a 90-degree angle, you cannot assume that they are perpendicular and should be given information. So this is a symbol for perpendicular. Okay, so perpendicular lines are represented by the symbol that I have shown below. So for the two specific lines that we can see here, we could say AB is perpendicular to XY. Okay, so you guys need to know this notation, because if you're doing exam questions and they give you this bit of information, if you don't know what it means, you're going to be missing an angle. Okay, then you will be like, I don't have enough information to complete this, when in fact you do. So we need to know what these things mean. So if you're given like an upside down T, that is the perpendicular line. It means where these two lines meet, we have a 90-degree angle. Okay, there we go. So if lines AB and CD intersect each other at a 90-degree angle, we can express it as AB upside down T, which means it's perpendicular to CD. Okay, now here's where the work starts. We spoke about gradients, right? Who remembers or who can tell me the formula for gradient? Let's see who's been writing notes in our lessons. What is our formula for gradient that we've been using? Yeah, I'm gonna give you guys a few minutes to type it out. I know it's not like, no, that's the formula for a linear graph or straight line graph. The M in your formula, Kutlwano, would be the gradient. So I want to know what the formula for working out the gradient is. MX plus C is not. Okay, Asande is getting somewhere. We're getting somewhere. There we go, guys. Thanks, Zianda and everyone else who helped. Okay, so we've been working out gradient by saying, let me scroll down a bit. By saying, thank you, Butlebenkosi, that's a nice way to say it, change in Y values divided by change in X values. So the gradient has been, okay, I'm going to move my writing pad because my writing is sideways and I don't understand. It doesn't look very good. There we go. Let's see if I can do this better. I'm going to move my writing pad. 2 seconds, guys, 2 seconds. I have so much stationery that will just like, I don't know what's going on. Whew. There we go. So we've been saying M is equal to change in Y, which means the Y of coordinate 2 minus the Y of coordinate 1 divided by the X of coordinate 2 minus the X of coordinate 1. So change in Y divided by change in X. Okay, now, if lines are perpendicular, so if they meet at a 90-degree angle, when you multiply their gradients, so you take this M and you multiply them together, you will always get a value of -1. Okay, so you get a value of -1. So depending on how much information you get, you can figure out whether two lines are perpendicular. Okay, so let's practice. Let's practice. There we go. I have 7 gradients over there. And we now have to figure out which of these 7 are perpendicular. I can tell you there's more than one pair that is perpendicular. So we need to find a few of these which are perpendicular to one another. Okay, let us, luckily we don't have to work out the gradient. First, we're already given the gradient, but we have to multiply those gradients and then check if they are equal to -1. And if that's the case, then we'll be able to identify. What is m equal to? M is the gradient, Dwayne. Remember we started with gradients? A few lessons ago, we were talking about gradients. Now let us check. Let us check which of the two gradients are perpendicular. You guys have to actually trial and error. Okay. Does anyone have any pair? Has anyone figured out a pair of gradients between the 7 that are perpendicular? Let's see. Yes, you would have to catch up those lessons, Dwayne, so that they are easier for you to understand because we're using the previous lessons work. Grade 9, Likona, and may I please have an answer, guys? We're not focusing. I'm going to block the chat. Okay, so let's start with the first two. If I say a half multiply, okay, Zianda says 1 and 5. Zianda has been working. 1 and 5 is what? Okay, let's see. A half multiplied by 1 and 6 or 5. I'm not sure. Okay, 6. 6 is 0.2 equals. Now a half multiplied by 2/10. These twos are going to cancel out. That's 1/10. That's definitely not -1. So those two lines we know for sure are not perpendicular to one another. Thank you for trying, Zianda. Thank you for trying. Remember, you have to give me a pair of perpendicular gradients, not just one, okay? 0.25 has to go with something else. What do we think, guys? So these ones we have tested and they are not perpendicular. Okay, let me move this chat. Perpendicular. So we know definitely that number 1 and number 6 are not perpendicular. Zianda was onto something though. Zianda, try again. I feel like you were onto something and you sort of could have understood what was happening in. I hope we are working where we are because we're very quiet. Which two are perpendicular? Okay, I'm going to try number 2 and 3. Okay, so -1/3 multiplied by -3 equals. Two negatives are going to give me a positive answer. Then it's going to be 1 times 3, which is 3/3, which is +1. Are these perpendicular? Are these perpendicular, guys? My answer is +1. Why not, Zeketelo? Why are they not perpendicular? Anyone? There we go. Thank you, Kutlano. They are not perpendicular because they are positive. Okay, so your answer has to give you -1, not +1. We were pretty close though. We were pretty close. So then again, these are not perpendicular. Bokang, do you have a question or have you figured out a pair that is perpendicular? Yes, Bokang.
Ma'am, I would like to ask, where did you get that -3?
I got it from number 3. So I tested between number 3.
Okay, then 0.2.
It was number 6. We need to keep up. So this one was number 6 and 1. So the first one was number 6 and 1. And then the second one was number 2 and 3.
Okay, ma'am.
2 and 3. There we go. Maybe I should write those down so we don't get confused. Okay. I see some people saying, oh, some people said 4 and 5. Some people said 1 and 7. I'm going to start with 4 and 5. Let's see. This is 4 and 5. Okay. So number 4 is 0.25. And we have number 5, which is -4. Let us test and see if these are indeed perpendicular. So number 4 is 0, of course, my 0 is going to look like some weird retarded gang sign. Number 4 is 0.25, and we're going to multiply with number 5, which is -4. Equals 0.25 can be rewritten as a quarter, okay? Times -4 over 1. A positive and a negative give you what? If you multiply a positive and a negative, what are we going to get? Thank you guys. A negative, okay? 1 times 4 is a 4. 4 times 1 is a 4. So the answer is -1. So are number 4 and 5 perpendicular? Are number 4 and 5 perpendicular lines? Yes, they are. I'm going to draw a happy face here and be like, yay, we found the first pair of perpendicular lines. That was number 4, number 5. Okay. Now let me go scroll in the chat and see what other options. Which other options did you guys say were perpendicular? I see 6 and 7. Ufenza says 1 and 7. Okay. Ufenza is very adamant that 1 and 7 are perpendicular. So let's test it. Okay. Let's see. Number 1 and 7. Okay. Number 1 is a half multiplied by -2. A positive and a negative give you what? What does a positive and a negative give you? Thank you. A negative, and we're going to have -2 over 2, which is -1. Nice, Ufenza. You have found our second pair of perpendicular lines, which is number 1 and 7. So, guys, I'm going to ask you something very interesting. I'm going to tell you first that those are the only 2 perpendicular ones. Okay. And then while I take Sibulele's answer, okay, for number 1 and 7, can we write? Yes, you can, Dwayne. I was just writing it as a fraction because I was simplifying and not using a calculator. But if you're using a calculator, then you're allowed to write it like that, okay? So while I take Sibulele's answer, I want you guys to tell me, what do you notice about the gradients of perpendicular lines? For instance, okay, number 1 and 7 were a half and -2. And number 4 and 5 was 0.25, which is basically a quarter and -4. There's something very specific about these numbers. Decide what you can see, send in the chat. And Sibulele, what's your question? Hello, you can unmute yourself. Sibulele, there we go. Never mind, mute it again. Yes, you can unmute yourself. Sibulele. I can hear you.
Okay. Oh, sorry. Hi. It's fine, Miss. I was also gonna say 1 and 7, but it's fine.
Okay, all right, Sibulele. Okay, guys. So what do we notice about these gradients that are? Okay, first thing we notice is one of them has to be positive and one of them has to be negative, which is the only way we're going to get a negative number. Okay, the only way you get a negative number is by multiplying a positive and a negative. Okay, Thank you, Simone, for a very nice clue there. We're looking for a magic word. Yes, Zekatelo, but what is that specific R word that says exactly what you're saying? The numerator for the one is the denominator for the other. What does it mean? What do we call it when we swap numbers around, guys? There we go. Sibulele. These are reciprocals of one another. I'm even writing with the highlighter the way. Oh, now I'm writing with the big guys. I don't know what's going on. Eee. Okay, these are reciprocals of one another. Okay, so that means, first of all, one of them has to be positive or negative. And then secondly, they have to be reciprocals of one another. If that is the case, then you will easily be able to identify perpendicular lines. Look at number 1 and 2 and 3, excuse me. They were almost perpendicular, but what is missing? They are reciprocals of one another, right? But they're both negative. So my two conditions have to be, they have to be reciprocal, and then they have to have opposite signs. So I feel like once you know this, it will be so easy to identify this. Ziana, reciprocals means they are basically upside down versions of one another. Do you agree, Zianda, that the number 4 can be written as 4/1? Maybe I shouldn't use red. It's not a good idea. The number 4 can be written as 4/1. Do you agree? Yes. So when we say reciprocal, we mean you swap the denominator and the numerator. So then now your 1 is your numerator and your 4 is your denominator. So look at all these numbers, Zianda. We have a 1/2 and a 2, which can be written as 2/1. We have a 1/4 and a 4/1. Do you see, Zianda? That's what we mean when we say they are reciprocals of one another. The one's denominator is the other one's numerator. You see? I hope Zianda can understand. Jackie, do you have a question? Hello, Jackie. You can unmute. You're welcome, Zianda. I'm glad you understand. Hi, Jackie. Hello. Okay. So just to check that we understand this concept of reciprocals. Okay. To me, that would be the reciprocal, but also they also have to have opposite sign, remember. Okay, let me explain it with different numbers. Okay, I have a gradient of 1/3. Okay, first, the perpendicular line has to have an opposite sign. So what is the sign of the perpendicular line? 1/3 is positive, so my perpendicular line has to be what? Negative. So I know that the gradient of my perpendicular line has to be negative. Now, guys, what is the reciprocal of 1/3? I'm going to explain it again. Reciprocal means swap the numbers. So if you have 2/1, okay, you're going to take 1 to the top and 2 to the bottom. So the reciprocal of 2/1 will be 1/2. Wonderful, guys. So the gradient of the perpendicular line will be 3/1, but we don't write 3/1. We usually write -3 because 3 divided by 1 is just 3. Do you understand, guys? Do you see, guys? Who was asking? I didn't see who was. Tshegofatso, do you feel better about reciprocals? So you swap them and then you change the sign. That is what a reciprocal is. I want to check if we still understand. So if I have a gradient of -3/2, what will the gradient of my perpendicular line be? Thank you. Thank you. Tiamo was way ahead of this. Let's start with the symbol. If the first one is negative, the second one will be? If the first one is negative, the second one will be positive. Now, my reciprocal means swap the denominators and your numerators. So 2 will go to the top and 3 will go to the bottom. How are we feeling, guys? Thumbs up, thumbs down. How are you feeling about this? There we go. Tsukhofatso. That makes me feel fabulous that you understand. Okay, I see thumbs up. If you don't understand, you really are allowed to say, I know there's a lot of information, guys. Do not be shy, okay? Okay, wonderful, 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 wonderful. Now, we know how to identify perpendicular lines, right? So, why did I divide by 10, 2 by 10? Where? I rewrote 0.2 as a fraction, Buhle Bengosi. 0.2. Remember, it is 2 divided by 1. And how many decimal places do you have? 1. So you only have 1 0. So all I did was rewrite 0.2 as a fraction. Okay. I saw a hand. Oh, is it still there? No, it's gone. Okay. Okay, now they're going to ask you, are these two lines perpendicular? Use the coordinates to prove your answer. Who has an idea? Yes, exactly. That's a good question, Slidile. Exactly 90 degrees, okay? If it's 95 degrees, not perpendicular. They're already off, okay? The gradients will be off and the lines will not be perpendicular. So guys, I want you guys to tell me, I'm asking you if these two lines are perpendicular. And then I'm giving you coordinates. What are we going to do? What are we expected to do with these coordinates? You're welcome. What do you think we are expected to do with these coordinates, guys? Any ideas? We'll ask, are the lines coordinates? No, are the lines coordinates? Wow, guys, English is chowing. Are the lines perpendicular? Thank you, Mali Bogwe. We're going to use these lines to calculate the gradient. You guys are superstars. So you first have to find the gradient of line 1, find the gradient of line 2, check if they are reciprocals and opposite signs, and then check if they multiply to -1. So let's do that. Gradient of line 1. Who wants to find the gradient of line 1 for me? M equals y2 minus y1. I actually am going to use letters because my coordinates have names, okay? My coordinates have names. So I'm going to say it's the y of b minus the y of a divided by the x of b minus the x of a. Now this will be what? I hope we are working with me. I hope so. Let me do this. Minus x of a. So what is the y coordinate of b? What is my y coordinate for b? Y coordinate for b. That would be -4. Beautiful. -4 minus y coordinate for A. Close Kuklano, but remember we're taking, there we go, -1. Oh, looks like some of us need to go revise coordinates, guys. X first, Y after. Okay, now this is A and that is B. So all the ones we're filling in here come from B, and all the ones we're filling in there come from A. We need to revise. Yes, Bokang? Bokang, you can unmute.
Ma'am,
Yes.
I would like to do the next one.
-1 minus, which one? The one that I just wrote.
Yeah, line 2.
Oh, okay. Let me finish line 1 quickly, Bokang. Okay. So this one is -4 plus 1 over what? -1. It is a negative. So it will be -3 over -1, which is just 3. Okay, I'm ready. Let's do line 2.
M is equals to YB minus YA.
Okay, well, in this case, it's E and F, right?
Okay.
Over YF minus YE. Okay, let's substitute.
Y -3 minus -2
Minus -2 over
over 3
3
minus 0.
minus 0 equals. Okay.
Is equals to negative.
You're right. The 3 is negative, right?
Yes, ma'am.
So you were doing well. Yes, -3. And then those two negatives, what's going to happen with them?
We're going to form positive.
Beautiful. So it's +2 divided by just 3. 3 minus 0 is just 3, right?
Yes, ma'am.
Equals. What's -3 plus 2, Boka?
-3 plus 2 is -1.
-1 over 3. Thank you, Boka, for helping me. That was fabulous. Thank you.
Yes, ma'am. Thank you.
Guys, I like it when people talk to me. Boka just made my day. Okay, we have 2 gradients. Are these 2 lines perpendicular? Are these 2 lines perpendicular? Offensive says no. Okay. Let's wait for others. Let's hear everyone else's response. Nope, we're not going to get a brain break if we don't work. Yes, Malibongo says no. Some people say yes. Sanila says no. No, 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 no. Oh, are these 2 opposite signs of one another? Let's start with the. Are these 2 opposite signs of one another? So 3 is positive, and the second one is negative. Beautiful. Okay. Are they reciprocals of one another? Let's multiply them and see what happens. Guys, calculators out. 3 multiplied by negative. Okay, guys, I'm going to block the chat if we don't cooperate, okay? I see a lot of us have jumped on the trend of saying yes, no, maybe, both, I don't know, whatever. Remember, we are here to learn. Okay, if we keep misbehaving, I will skip the brain break. I have one, but I will skip it and we will continue working. Okay, now 3 times -1 over 3 equals a positive and a negative gives you Yes, guys, it's a negative. And 3 times a third is 1. So these are indeed perpendicular. Yay! Whoop, whoop. Well done, Farida, for knowing they are perpendicular. So guys, if you still can't identify them, that's fine. Just do the calculation. But if you just look at these, 3 over 1 is the reciprocal of 1 over 3. And they're opposite signs, so they have to be perpendicular. Slindile, do you have a question?
Hello, ma'am.
Hello.
Ma'am, I just wanted to ask you said that question that says in line 2. I think you made a mistake. I'm not sure. You said 1f minus ye
Mhm.
over yf. I think it's supposed to be x, ma'am.
Oh, yes, it is. It is beautiful for spotting it. Did I use the correct coordinates though? I think I used the correct coordinates. Let's see. X of f is 3 and x of e is 0. Thank you very much. Luckily, I used the correct coordinates. Thank you, Slindile. Okay, Zianda, do you have a question?
Hi, ma'am. Can you hear me?
Yes.
And I wanted to help you with the next one.
Okay, let's do it. Let us do it. We will end off with our brain break. How's that? Brain break will be the last thing we do before we go to the quiz. Okay, let's do it. Let's go for it, Zianda.
I'm gonna do line 1.
Okay.
So we're gonna say m equals y2 minus y1 x over x2 minus x1.
Beautiful. Now let's substitute.
And then you're gonna take your 3 minus 2.
Are you sure? Remember, it's the other coordinate.
I remember, what did I do?
So it's the y for A, which is 3, but what's the y for B?
I mean 4.
There we go. Over.
2 minus 0.
And 0. Beautiful. What's next?
And then your 3 minus 4 is going to equal to 1.
Just 1?
Minus 1, negative 1
Over
over 2.
2.
Yes.
Beautiful. Thank you.
Welcome.
Okay, let's hear what Slindile has to say. Yes, Slindile.
Ma'am, can I try line 2?
Yes. Let's go for it.
Okay. M equals y
Oh,
ye, ma'am.
there we go. YE. We couldn't hear you. YE minus
Minus yf is minus 1f
over
over xe minus
minus. Hello.
xf
Here we go. XF. Okay, let's substitute.
equals to 3 minus 7
Over
and minus 7
1.
over 1 3
minus 3. Okay. Ooh.
Equals to
negative
-4
over -2. What's -4 over -2? It is, Tiamo.
2.
Yes, it is. +2. Beautiful, Slindile.
Yes, ma'am.
Okay, guys. Are these two lines perpendicular? Are these two lines perpendicular? Oh, I see. Yes, 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 yes. Let's see. -1 over 2 multiplied by 2 equals how much? Yes, they are reciprocals, Farida. And it equals to -1. So these are indeed, I'm gonna write in blue. These are indeed perpendicular with a smiley face. Beautiful, guys. Now, that's great, Tando.